Hey there, it's Mr. Leatherwood. Today we're going to do adding integers using a number line. Hopefully you've watched my other video about adding integers using negative and positive chips. I think it'll help. But today we're going to use a number line and see how you do. So first we're going to start with negative 3 plus negative 2. So I'm always going to start at 0. So let's do our little 0 on here. And then my first number is just where I'm going to skip to first. So for instance, I'm at 0. My number sentence starts with negative 3. So I am going to go back 3. And if we do that, that's going to get us to negative 3. And then I'm going to add negative 2. Well, we know if we add a normal 2, just a positive 2, we would go to the right. But in this case, we're adding the opposite of that. So instead of going to the right when we're we're going to go to the left this time. So I'm going to hop 2 more spots. And if I go 2 more spots to the left, I'm going to get to negative 5. So negative 5 ends up being my answer. Negative 3 plus negative 2. And if you think back at the counter chips, if you've watched that video, we started with 3 negative chips and we added 2 more negative chips, which would also get us to negative 5. So it's very similar, just a different representation of our model. Let's try another one here. How about negative 5 plus negative 7? So again, I'm always going to start at 0. And my first number in the number sentence is negative 5. So I'm going to hop back 5 spots. And I'm probably going to run out of room because I didn't do a very good job here drawing. So now I'm at negative 5 and I'm going to add negative 7. So if I'm adding a normal 7, I'm going to the right 7 spots. In this case, I'm doing its opposite. So I'm going farther to the left. So I'm going deeper into my hole. So I'm going to go, we're going to say that's 7 hops. We know it's probably not. But, so we're going to do 5 and 7. So if I did 7 more hops to the left, we know that that's going to get me to negative 12. And again, on this one, if we did the chips, we have 5 negative chips, and then we're adding 7 more negative chips, so we end up getting to negative 12. So it works the same way here. You may have noticed a trend. So when you're adding integers with the same sign, you can add the absolute value. So for instance, if we talked about our negative 5 plus negative 7, our absolute value of these is just the distance from 0, right? So it would be 5 plus 7. And then it says if they're positive, if both integers are positive. Well, in this case, they were both negative, so we go to the next one. Negative if both integers are negative. So that's why we would get our negative 12, because both of these, look at my little laser pointer, they started with negatives here. So just like with our chips, when we were adding 5 negative chips and 7 negative chips, well, obviously we're going to get a negative answer. But these are kind of some rules that you could go by. You know me, I'm not a big believer in rules. I'd rather you figure out the why. All right, let's take a look at some more. So this time, they're a little different. So we have numbers that are different signs here. So same thing, I'm going to start at 0. And then whatever my first number is, that's what I'm going to hop to first. So in this case, it's 5. So I know that I need to go this way this time, because 5 is a positive number. We're going to say my 5 is right here. And then I'm going to add negative 3. Well, if I'm adding a positive 3, I would go farther to the right. But in this case, I'm adding the opposite of 3, basically. So I'm going to hop back 3 spots. And if I hop back 3 spots, we know that that gets me to negative 2. Oh, not negative 2. Bad, Mr. Leatherwood, not negative 2. Boop doop. There we go. A positive 2. Because we were at 5, we hopped back 3 spots to the left, so we know that our answer is going to be positive 2. Okay, so even though we went backwards, or we subtracted here, you notice we're still in the positive. Let's try one more. All right, so this time we're going to start in the negative. So I'm going to start at 0. I'm going to hop back 3 spots, which gets me to -3. And then I'm going to add 2. Well, we know if we add 2, just from way back when we learned how to do things on a number line, that we're just going to the right 2 spaces. So I'm just going to hop to the right 2 spaces. And we don't quite get back to 0. We actually get back to -1. So our answer there is going to be -1. And again, if we refer back to our counters, if we started with -3 and then we added 2, we would have 2 0 pairs, and it would still leave 1 negative chip. So similar there, just to give you a little bit more representation there. There are some rules when you're adding integers with different signs as well. So when you're adding integers with different signs, this time you're going to subtract their absolute value. So let's say we had 5 plus -7. So those are different signs. We're going to subtract their absolute value. So the absolute value of 5 is 5, and the absolute value of -7 would be 7. So we're going to take 7 minus 5. That's going to give me 2. So we know the answer has to do with 2. It's positive if the positive integer's absolute value is greater. Well, in this case, it's negative because the negative integer's absolute value is greater. Very confusing. So what we're going to look back at the original problem, and we're going to say, which one of these is the larger absolute value? Well, in this case, 7 would have the larger absolute value, and since it's a negative, that means we're going to take that negative and we're going to make it in our answer. So our answer ends up being -2. And if you go back to our previous time that we did this problem, 5 plus -7, we are going to get -2. And you can try that with your counters. You can try that with your number line just to verify that that's correct. All right, well, hopefully this helped you out. Now you've done counters, you've done number line, and eventually you should be able to do it without models to do addition of integers. All right, thanks a lot, and see you next time.